We are discussing the annual examination question paper of physics for class 9. The first section contains 5 questions, each carrying 1 mark. We shall to answer 4 questions. In the second section also, there are 5 questions, each having 2 marks. Here also, we have to attend 4 questions. In section 3, there are 5 questions having, and here also we have to answer 4 questions. There are 5 questions having 4 mark each, and we shall to answer 4 questions. Using the relation in first word pair, complete the second. Voltage, voltmeter, electric current, dash. Voltmeter is used to measure the voltage. Ammeter is used to measure the current in a circuit. So answer is ammeter. Which of the following represents a positive uniform acceleration? Here we shall given 4 graphs. In the first graph, the velocity decreases as the time increases. So here there is a negative acceleration. In the second graph, the velocity is constant, which means that there is no acceleration. The third graph, velocity increases as time increases, and it is a positive uniform acceleration. The velocity changes continuously when time increases. Which graph represents a positive uniform acceleration? Here it is graph A. A body of mass 50 kg can climb a mountain of height 30 meter in 5 minutes. What will be his power? This is the equation of power. Power is equal to work divided by time. P is equal to mgh divided by t. M is 50 kg. G is 10 meter per second square. And the height of the mountain 30 meter. The time taken 5 minutes, which is equal to 5 into 60 seconds. Power is equal to 50 into 10 into 30 divided by 300, which is equal to 50 watts. Which of the following is the correct relation between frequency, wavelength and velocity of a wave? V is equal to F lambda. So F is equal to V divided by lambda. So here is the answer. F is equal to V divided by lambda. Find the odd one out from the following statements and give reason. A man standing with a load on his head. It has no displacement. A man climbing a ladder with a load on his head. It has displacement. A boy is pushing a wall having no displacement. 2 persons pushing a table from opposite sides with equal force. Here also there is no displacement. So the answer is a man climbing a ladder with a load on his head. Work is said to be done only when a body undergoes displacement in the direction of the applied force. Classify the following in the given table. Those which need a medium for propagation, those which do not need a medium for propagation. So here it is the table 7.1. Waves formed on water surface and sound waves needs a medium for their propagation. But radio waves and light waves needs no medium for propagation. From the figure, identify the equipments used for the following purpose. To measure the current in a circuit without connecting wires. Clamp ammeter helps to measure the current in a circuit without connecting wires. Soldering iron is used to solder electronic components in a circuit. To solder electronic components in a circuit, we use soldering iron. Car is moving with a uniform velocity 20 meter per second. It is brought to rest by applying brake uniformly for 5 seconds. What is the retardation of the car? The acceleration of the car is equal to change in velocity divided by time. A is equal to V minus U divided by T. So retardation A is equal to V minus U divided by T. V is 0. U is 20 meter per second, T is 5 seconds. So A is equal to 0 minus 20 divided by 5, which is equal to minus 4 meter per second square. Minus indicates the motion of the car is in retardation. The negative acceleration. Now what is the displacement of the car during this time interval? According to second equation of motion, S is equal to ut plus half at square. Now given u, t and a, substitute, we will get S is equal to 50 meter. Displacement of the car during this time interval is 50 meter. Find the carriers of electric current in each of the following. Current is formed in conductors by the flow of free electrons in it and by the flow of ions in gases and electrolytes. Copper wire and nichrome are metal conductors, so free electrons are the carriers. Common salt and gases, ions are the carriers of electric current. Distinguish between reverberation and echo. Reverberation is the persistence of sound as a result of multiple reflection. Echo is the phenomenon of hearing a sound by reflection from a surface or obstacle after hearing the original sound. Observe the figure. Name the instrument depicted above. Write the principle based on which this device is designed. For what purpose do we use it in a circuit? This is rheostat. For a conductor of uniform area of cross section, the length of the conductor and its resistance are directly proportional to each other. Rheostat is a device designed on the basis of this principle. What purpose do we use it in a circuit? The resistance of the circuit can be continuously changed by sliding the contact. The change in resistance regulates the current. So, rheostat is a device used to regulate the current in a circuit by changing the resistance gradually. Give reason for each of the following. Musical instruments like trumpets and shehnai have conical shaped opponents. In such devices, there is a conical shaped opponent which enables the reflected sounds to travel in a particular direction alone, thus enabling us to hear it louder. The ceilings of halls are given a curvature. Sound generated from a source spreads all over the hall due to multiple reflection. So the ceilings of halls are given a curvature. The floors and walls of auditoriums are made rough to increase the audibility and to avoid the multiple reflections. We make the floor rough. Correct the mistakes, if any, in the following statements by modifying the underlined words. Water shows capillary depression in a capillary tube made of glass. Water is a liquid which shows capillary rise. Here mercury shows capillary depression. So, mercury shows capillary depression in a capillary tube made of glass. The attraction between the molecules of different types of substance is called cohesive force. The attraction between the molecules of same type is called cohesive force. Adhesive force is the force of attraction between molecules of different types of substance. So the attraction between the molecules of different types of substance is called adhesive force. After a while of an electric shock, the body temperature of a person increases, and subsequently the viscosity of the blood increases. Viscosity is a frictional force parallel to the layers which try to prevent the relative motion between the layers. The body temperature of a person who gets an electric shock falls suddenly. As a result, the viscosity of the blood increases. The body temperature of the person decreases, and subsequently the viscosity of the blood increases. Select and write the statements which are suitable for longitudinal waves. These are longitudinal waves which contains compression and rarefaction. The particles inside the waves moves parallel to the direction of motion of the wave. The particles of the medium vibrate in a direction perpendicular to the direction of propagation is transverse wave. Propagated by compression and rarefaction is a longitudinal wave. Sound waves are longitudinal waves. Ripples formed on still water surface is a transverse wave. The particle of the medium vibrate in a direction parallel to the direction of propagation is a longitudinal wave. Wavelength is measured as the distance between two consecutive crusts or troughs is a transverse wave. So the answer is B, C and E. The resistance of a conductor of length L meter and area of cross section A meter square is given by R is equal to rho into L by A. What does rho indicate? Rho is the resistivity of the material. Write the situation in which the value of rho of a substance changes. The resistivity of a substance is a constant at fixed temperature. So temperature changes, the resistivity changes. Which of the following is correct for a copper wire and an aluminum wire of equal length and thickness? They have same resistance. Is wrong. They have same resistivity. Wrong. Both of them have same resistance and same resistivity. Wrong. Their resistance and resistivity are different, which is correct answer. Their resistance and resistivity are different. A body of mass 2 kg is falling down freely from rest with the value of g as 10 meter per second square. What is its velocity at the end of 2 seconds? Here we have v is equal to u plus at. Given that initial velocity u0, acceleration g is equal to 10 meter per second square, and the body takes 2 seconds to fall. So v is equal to 0 plus 10 into 2, 20 meter per second is the velocity of that body. Calculate the change of momentum during this time. This is the change of momentum. mv minus mu. M is equal to 2 kg. V is equal to 20 meter per second. U is 0. 2 into 20 minus 2 into 0. So 40 kilogram meter per second. Find the impulse of force acting on this body at this time interval. Impulse is equal to the change in momentum. The answer is 40 kilogram meter per second. Name the principle relating impulse and change of momentum. Impulse is equal to change in momentum. This is known as impulse momentum principle. A body of mass 10 kg is taken to different parts of the earth. What is its mass at the center of earth? The force of attraction body on earth's surface is gmm divided by r square. Force is inversely proportional to the square of the radius. The radius is greater at equator, so the force is less at equator. Here the radius is less and the force is greater. So what is its mass at the center of the earth? The mass of a body never changes. The mass is constant, which is 10 kg. Where does it have maximum weight? Weight means the force of the body. The force of the body is maximum at poles because the radius is less. At which part on the surface of the earth the weight is minimum? The force is minimum at equator because the radius is greater at equator. In your opinion, what is the cause of this difference in weight? It is due to the difference in radius of earth. Identify the types of mechanical energy possessed in the following situations. A stretched spring, a bullet fired from a gun, water stored in a tank at a certain height, a bird flying at a certain height with a constant speed. This is a stretched spring. Here the energy is called the potential energy due to strain. Here a stretched spring possesses potential energy. A bullet fired from a gun possesses kinetic energy. Water stored in a tank at a certain height, potential energy. A bird flying at a certain height with a constant speed, potential energy as well as kinetic energy. Observe the following circuit and answer the questions. A battery in the above circuit can provide a potential difference of 8 volt. Find the EMF of one cell if they are identical. Here we have 4 identical batteries. The total voltage is 8 volt. So, the voltage of a single cell is 8 divided by 4, 2 volt. When the voltmeter reading is 0.3 volt, the ammeter reading is found to be 0.15 ampere. What will be the resistance of the wire X? According to Ohm's law, the resistance R is equal to V divided by I. The resistance of X is equal to V divided by I, where V is equal to 0.3 and I is equal to 0.15, which is equal to 2 ohm. What will be the voltmeter reading when the ammeter reading is made 0.3 ampere by adjusting the rheostat? The resistance of this conductor is constant and which is 2 ohm and the current increases. Now what happened to the voltage? According to Ohm's law, the current increases, voltage also increases. Here V is equal to I into R. The new current is 0.3 ampere. The resistance is 2 ohm. So 0.6 is the potential across this conductor X. State the law which help you to answer the above. Ohm's law. When temperature remains constant, the current through a conductor is directly proportional to the potential difference between its ends. Sound waves from sonar in a ship hits the bottom of the sea and comes back after 1 second. Calculate the distance to the bottom of the sea from the ship. Speed of sound in sea water is 1522 meter per second. It is the sonar. This is a device which is used to measure the distance of objects underwater. Here we use ultrasonic waves. The sound travels from ship and it reflects under the sea and back to this ship. So let d be the depth of the sea. The sound travels 2d distance. So the distance traveled by sound 2d is equal to velocity of sound into time. So we have the time is 1 second and the velocity is 1522. 2d is equal to 1522 into 1, which is equal to 1522 meter. d is equal to 1522 divided by 2, which is equal to 761 meter. So the depth of the sea is 761 meter. Which type of sound waves is used in sonar? Ultrasonic sound. Write any other two use of this type of sound wave. Echocardiography, ultrasonography.